PCR or polymerase chain reaction is a lab technique for amplifying specific fragments of DNA, generating millions to billions copies of the target sequence in a few hours. This process occurs in a thermal cycler that is going to be loaded with the reaction blend, which is composed by naked genomic DNA or not inserted in a cell nucleus, the NTP or deoxynucleotide triphosphates that are the building blocks for the new DNA copies. They are needed for the DNA strand extension. Synthetic primers or short DNA sequences that are designed to bind specifically to complementary region of the DNA template. Taq polymerase, that is a bacterial enzyme, and finally Mg2+ ions are essential cofactors for the Taq polymerase enzyme. Now we are going to describe you the main steps. Initially there is the DNA denaturation. In this phase, the DNA double-stranded is subject to elevated temperatures between 90 and 95 Celsius degrees that causes its unrolling with the breaking of hydrogen bonds between complementary bases. In the next step, the temperature is lowered to 70 Celsius degree, allowing specific synthetic primers to bind to the original sequences. This stage is called DNA annealing, a term used to describe the reformation or renaturation of reverse complementary strands that were separated by heat. We have to use synthetic primers because human ones would die at such high temperatures. Finally, the chain is lengthened adding complementary DNTPs thanks to the Taq polymerase during the extension phase, plus help primers in their work during this phase. All this process is repeated 35 times in sterilized laboratories in order to avoid the contamination of the solution. In this way, it's possible to obtain 2 to 35 copies of DNA fragments in about 2 hours.